In this part, we will look at miscellaneous things. Okay, basically everywhere else where the application of derivatives is going to be applied. We do not have a specific formulation for all of this, okay, but you will find the questions based on these topics in different areas. Looking at everything in general, I can easily say that these are applications based which are solved in physics. If you look at certain areas in physics, application of derivatives is there. Okay, so in this part, let's study what are the practical applications where all do we find derivatives. Okay, now in this part we'll be studying miscellaneous. Now what does miscellaneous actually mean would be a little tricky for you to understand, but it's not that. Let's say there are different factors. All right, simply understanding, let us take this one condition. All of you play different kinds of car games, right? NFS, street, and other games like that. All right, now when I'm driving a car, there are two things, right? One is speed and the second is acceleration. Now, what is speed and what is acceleration? Okay, now the rate at which the car is moving, that is basically the speed, right? Let's say I cover some distance with particular speed. Okay, so let's say if my distance is A and my time is T, okay, then dA by dt is what my speed is, right? For a unit distance, the unit time taken, right? That is what my speed is. So if I differentiate 1 unit of that, if I take dA and divide it by dt, that is what my speed is, right? So in the application of derivatives, calculating speed is one of the most commonly used derivative, right? dA by dt, when I apply for speed, this is the most common one in practical life. Now this will also be important for you in physics. Okay, so keeping that in mind, we need to know that dA by dt. Now what is acceleration? Acceleration, let's say I was moving at the speed of t, at the speed of 40. Now I am looking at my watch and I am seeing that I might fall short if I don't drive fast. So what do? I increase my speed. So when I increase my speed, I basically press the accelerator, right? Accelerator. So when I press my accelerator, I get acceleration, right? And that gives me a rise in speed. So what does that happen to do? That is the second derivative of speed. It is the, if you differentiate speed for the second time, that becomes acceleration. Okay, now this is an important aspect. This is just for the sake of understanding, knowing. There will be questions based on that, the rate of change and all that thing. Its example started with the previous question that we solved, right? Means how the shadows will lengthen and all that, at the rate of which the shadows will lengthen. So that was based on one of the applications of derivatives. Now let's move on to the next part. Let's say I have a guy who is carrying a rod like this and he is walking. Okay, so you see his face, he's smiling, right? Now he has to go through a path like this. Let's say when he comes, he is about to make a turn over here. You see his rod, right? Let's extend its rod to be a little bit more lengthy. Okay, now this rod is getting stuck over here, right? If he is moving in an L shape, it is getting stuck over here, right? So basically he now has to either change or put some understanding. Here the concept of maximum minima that we studied comes to play. What should be the maximum size of this to get through this, right? So that is the application part of maxima and minima, right? There would be questions based on that, not at this level maybe, but at the higher level. But just to understand this, there has to be a minimum length also, okay, minimum length of the rod so that it moves smoothly. What could be the maximum length so there is no trouble over here? So in that case, I apply the concept of maxima and minima. Now, let's move forward. This is the most commonly used application of derivative in mathematics. There are a lot of questions based on this. Everyday morning schedule. This is an everyday morning schedule for everybody, filling up the bucket. Not unless if you take a shower, but even if you take a shower, the same concept applies. Let's say there is a certain rate at which the water is dripping. The volume of the bucket is known, right? So how much time will it take to fill the whole bucket? So calculating time, okay, important. If the rate is known, okay, I know the rate, okay, let's say the rate is given by, now the rate, or in some cases it is given, okay, let's say dA by dt. In some cases you need to find out. And how do I find out using that? You see this tap is in the form of a circle, right? So in this circle there is some area, right? So basically we need to calculate that area and then differentiate it with respect to time. That will give me the rate of the water falling, okay? Based on that, how much time will it take to fill up this area? And if this is in the form of a cylinder, it's easy. If not, then you need to use the other formula. Alright, so this is one of the application. Next, again, same with the bucket. If you punch holes into that, you see, this is a very hurt bucket. So many band-aids applied. Okay. Now, in this case also, the volume is given to you and it is said that the water is filled, right? The water drips out at a particular rate. Okay, let's say this is also given to you. You need to find out if based on different numbers of holes, how much time will it take so that the bucket is emptied out or at the minimum point. It will be given, but in most cases the question will always be asked that to empty the bucket there would be another hole over here and the water will be gushing out. Okay. So these are the most commonly used applications. Okay, you have to do nothing over here. You need the volume and you need know this part, the rate. So what you do is you divide the volume by this rate. That will give you the time that will be taken. Alright. So this is all the applications that we have in applications of derivative. This is the point of studying all of this is you know the application part in different mathematical areas. The practical areas is where these are the cases where we apply all of them. There would be questions that would be based on this, okay, but these are mostly based on practical applications. Alright. So that was miscellaneous. I am damn sure that that was the most interesting part for you, and I am sure that you all might have found it to be very funny. But in each part, I hope you get the understanding what is the practical application of it. Like basically when the water is fizzing out through a tap, when the water is pouring out of a broken bucket. So these are the practical examples, you know. You might think how is it important right now, but when you pursue this in physics, you will understand in different Bernoulli's theorem, etc., that these are very important. So that was all about application of derivatives. So we looked at the miscellaneous also. You have a deeper understanding basically how application of derivatives is important. Now let's look at some questions. These are the questions that have previously come in IIT-JEE exams. Okay, so here are few questions that have already come in IIT-JEE exams. Let's look at those questions.